So when we dealt with stoichiometry in the past, it was usually starting with a mass of one of our reactants, and so we took those grams, we used the molar mass of that material to convert it to moles, and then we were able to use these coefficients in the balanced equation to allow us to make the relationship from one substance to another. But when we're dealing with solutions, we can't deal with just the volume that we have, because with solutions are mixtures. Mixtures by definition have variable compositions. So you could have a very dilute solution which doesn't deliver a whole lot of your reactant, or you could have a very concentrated solution which delivers a considerable deal more. So when we are dealing with stoichiometry that involves solutions, we need to know two things. We need to know how much of it, the volume that we are adding, and we need to know the concentration of the solution. So in our example here, we are going to take and start off with 75 milliliters of aluminum nitrate solution, and that aluminum nitrate solution is going to be a 0.01 molar solution. Now, starting with that amount, we can use that information to help us determine how many moles of aluminum nitrate are we starting with, and the question here would be how much of that sodium oxide would we need to use to react in order to produce the aluminum oxide, the Al2O3, which is a precipitate. So if we're going to answer this question, we need to first start out by determining how much of that aluminum nitrate do we actually have. So to begin, we're going to take the volume and we're going to multiply it by the concentration to get moles. You'll notice that I converted the milliliters into liters, all right, from the 75 milliliters, so that the liter units will be able to cancel out. The next thing that we need to do is, now that we're in moles of aluminum nitrate, we need to use our mole ratio to go from talking of moles of aluminum nitrate to moles of sodium oxide. Now that we are in terms of the substance that we are interested in, so now we're going to use the molar mass of sodium oxide to convert into grams, and the molar mass of sodium oxide is 61.98 grams per mole. So when we do the math, we multiply across our numerators, then we divide by the only value we have in the denominator, which is a 2, we should come up with a final answer of 0.0697 grams. And another way to express that would be 69.7 milligrams of Na2O. So as you can see, we have the basic setup of a stoichiometry problem. The difference here when you're dealing with solution stoichiometry is your first step is to figure out just how many moles of your starting material do you have, and you do that by multiplying the volume that you're using by the concentration of that solution.